In previous videos, I have taken some examples on equivalence relation. That is the continuation of. This is the continuation of that video. Equivalence relation. Some problems may be asked. I already explained what is equivalence relation. When you say that relation is equivalence, it is reflexive, symmetric, as well as transitive. Then we say that relation is equivalence. Now consider this example. Prove that the relation congruent modulo m is an equivalence relation. Congruent modulo m means in number theory. Next topic we will come across in detail about congruent modulo m. Congruent modulo m means it is defined like this. We say that A is congruent to B mod m if and only m divides A minus B. See, this is the relation here. What is the relation? We say that three lines are there. A is congruent to the relation B mod m if and only m divides A minus B. Now prove that congruent modulo m is an equivalent relation. This is the given relation. We have to prove that this relation is reflexive, symmetric, as well as transitive. Now, first of all, this relation is reflexive. Why it is reflexive? So I give the reason why it is reflexive. We have A is congruent to A mod m. Why A is congruent to A mod m? Because m divides A minus A. That is m divides 0 is true. Any integer divides 0. M is non-zero integer here. A and B are any two integers. Therefore, m divides A minus A. That is m divides 0 is true. Hence, A is congruent to A mod m. It is reflexive. Secondly, this relation is symmetric. Symmetric means suppose A is congruent to B mod m. What does this imply? M divides A minus B. Now using property of divisibility, see we use this property. If A divides B, then A divides minus B. This is the property of divisibility, and you are supposed to study this in detail in number theory, property of divisibility. Now I give the statement only here. If A divides B, then A divides minus B. Now m divides A minus B implies m divides minus of A minus B. That is m divides B minus A. Now see the definition. Congruent modulo m. If m divides A minus B, A is congruent to B mod m. Here m divides B minus A means B is congruent to A mod m. So A is congruent to B mod m implies B is congruent to A mod m. So what do you get? Relation is symmetric. A is B mod m implies B is A mod m. Therefore relation is symmetric. Now only you have to prove that it is transitive. To prove that relation is transitive, equivalence, this relation is transitive. Let A is congruent to B mod m and B is congruent to C mod m. Now transitive means here the relation is congruent modulo m. A is congruent to B mod m. Suppose that B is congruent to C mod m. What do you have to prove? To prove that relation is transitive, you have to prove that A is congruent to C mod m. Then it becomes transitive. Now, what do you mean by A is congruent to B mod m? M divides A minus B. What do you mean by this? M divides B minus C. Again, we use property of divisibility. What is the property? If A divides B, A divides C, then A divides B plus C. This is next property of divisibility. Now we have M divides A minus B, M divides B minus C. Therefore M divides A minus B plus B minus C. Therefore M divides A minus C. By definition of congruent modulo M, M divides A minus C means A is congruent to C mod M. So A is congruent to B mod M, B is congruent to C mod M, implies A is congruent to C mod M. Hence it is transitive. So this relation, what is the relation? A is congruent to B modulo M is reflexive, symmetric as well as transitive. Therefore this relation is an equivalence relation. You may get some more examples, and for 5 marks this type of problems will be asked. What is the problem? Prove that following relation is equivalence relation. Now next topic is equivalence classes or equivalence sets. First I take example for this equivalence classes, or it is also called equivalence sets, and explain the notation. What is the notation for equivalence classes and what is the use of these equivalence classes? While defining partition of a set, we require these equivalence classes. Example is like this. Let A be the set of all triangles. Set of all triangles. Triangles means always we consider plane triangles. Triangles in the plane. Now R be an equivalence relation. Equivalence relation in A defined by X is congruent to Y. S is congruent to Y. See the example. A is set of all triangles, plane in a plane. Now we have defined equivalence relation here. How we have defined equivalence relation? X is congruent to Y. Let A belongs to E. Then the equivalence classes determined by A means all the triangles belonging to A, all the triangles in the plane A which are congruent to A. That is the equivalence class determined by A. Understand the definition? Here there is a non-empty set. What is the set? Set of all plane triangles. And one equivalence relation is there. What is the equivalence relation? X is congruent to Y. Now, suppose A belongs to A. Then, equivalence class determined by A means it is all the triangles belonging to A and congruent to A. Or equivalence class A can also be defined like this. In terms of mathematical language, we write equivalence class A is set of all x such that x belongs to A and xa belongs to R. xa belongs to R. See, this is another notation. What does this imply? Exactly, it is this. All the triangles belonging to A and congruent to A. That is the equivalence class determined by A. Now suppose another element B belongs to A. Another triangle is there. Equivalence class determined by B means all the triangles belonging to A, set of all x belongs to A means all the triangles belonging to A and they are congruent to B. Congruent to B. This is equivalence class determined by A, equivalence class determined by B. Now the important thing is these two we can have different equivalence sets or equivalence classes here. Equivalence classes. I define C is, suppose another element belonging to A. Equivalence class determined by C means all the triangles which are congruent to C and belonging to A. They must be in the set A only. In the set A, but they are equivalence class determined by C means they are the triangles in this set A but are congruent to C. Now, these ABC, what do you observe here? ABC determines different sets here. Different sets. The important thing is either these ABC equivalence classes determined by ABC are they are disjoint or they are identical, because suppose some triangle which is congruent to A, which is congruent to B also, then A must be same as B only. A must be same as B. Therefore, what is the property of these equivalence classes? Equivalence classes means their property is they are disjoint or mutually disjoint or identical. Important property. Equivalence classes means we define like this. Equivalence classes. Equivalence classes are either identical or disjoint. This is one example from which you can understand that equivalence classes. Equivalence classes. Now, to clear this concept, equivalence classes or equivalent sets, I take one more example. Examples makes the definition always clear. I take one more example for this equivalence classes. Now, let I be the set of all integers. Set of all integers. And define a relation congruent modulo m, congruent modulo phi. Congruent modulo phi. In I define congruent modulo phi, then it is an equivalence relation. An equivalence relation. This congruent modulo m is an equivalence relation. In the previous this video, I have put the first example as this one only. Congruent modulo m is an equivalence relation. Now, this I is set of all integers and the relation is congruent modulo phi. It is an equivalence relation. Now, I define this set like this. Suppose 0, all the integers which are congruent to 0 mod phi is denoted by this 0, or it is I0. Understand? I define this set now 0, which consists of all the elements which are congruent to 0 mod phi. What is that? First is 0. Then phi is also congruent to 0 mod phi, because phi is congruent to 0 mod phi. Why phi is congruent to 0 mod phi? Because phi divides phi minus 0. Congruent modulo phi. How to define congruent modulo m? Congruent modulo m means they are defined like this. Congruent modulo m means A is congruent to B mod m if m divides A minus B. M divides A minus B. Correct? Phi u divides phi minus 0. Therefore, phi u is congruent to 0 mod phi. 10 is congruent to 0 mod phi. 15 and so on. And minus phi is also congruent to 0 mod phi. Minus 10 and so on. Therefore, this 0 equivalence class determined by 0 means all the integers which are congruent to 0 mod 5 belong to this set. Second is equivalence class determined by 1. Equivalence relation is congruent modulo 5. It consists of this 1, 6, then 11 and so on, or minus 4, minus 9 and so on. Verify this. Why 6 belongs to this set? Because 6 is congruent to 1 mod 5. 6 is congruent to 1 mod 5. Why 6 is congruent to 1 mod 5? Because 5 divides 6 minus 1. So 6 is congruent to 1 mod 5. So 11 is also congruent to 1 mod 5. 11 minus 1 is 10. 5 divides 10. Now this complete set. What is this set? All the integers which are congruent to 1 mod 5 is denoted by this set 1. Second, similarly 2, 3 and 4. Now interesting thing is, let me explain. What is 2? The equivalence class determined by 2 here. Equivalence class belong, the equivalence class determined 2 is 2, then 7, 12, so on, minus 3, minus 8 and so on. Because this consists of congruent mod, 2 modulo 5. Congruent to 2 modulo 5. What is that? 7 is congruent to 2 modulo 5. 3 makes 3, 8, 13, so on, minus 2, minus 7. And 4. Congruent modulo 4. 4 means 4, 9, and what is the next one? 14, so on. Minus 1, minus 6, etc. Now we have 5 equivalence classes here. This congruent modulo 5 is an equivalence relation in I, and it determines 5 equivalence classes. What are they? 0, 1, 2, 3, 4. Sometimes it is denoted by I1, I2, I3, I4 also. Now, why there are only 5 equivalence classes here? 0, 1, 2, 3, 4. Because if I take 5, then that 5 is same as 0. 5 is same as 0 because 5 equivalence class determined by 5 means all the integers congruent to 5 mod 5. 5 mod 5 is same as 0 mod 5. 5 mod 5 is same as 0 mod 5. Equivalence class determined by 6 is same as 1. 7 is same as 2. Equivalence class determined by 3, 10 is same as 8 is same as 3, and 9 is same as 4. Therefore, there are only 5 equivalence classes. And what you observe here by these equivalence classes, this is important. This leads to an important definition in set theory. Important definition, these equivalence classes. Now, property of these equivalence classes is these 0 equivalence classes 0, 1, 2, 3, 4. Only there are 5 equivalence classes determined by this equivalence relation. These are mutually disjoint. Mutually disjoint. What do you mean by this mutually disjoint? Because they have no common elements. This 2 consists of 2, 7, 12, minus 3, minus 8, so on. But the elements in this equivalence class 2 is not common with any other set. That means all these equivalence classes are mutually disjoint. Second is the union of this 1, etc. 4 is I. Union of these sets is I. For this one, they are mutually disjoint. Their union is same as set of all integers. If you take the union of these 5 sets, that becomes set of integers. And third one is integers in the same group have the relation congruent modulo 5. Integers in the same group have the relation congruent modulo 5. 5. It is 0, congruent modulo 5. 5 is it is congruent to modulo 5. But different elements or elements in the different sets, they have not having this relation. Not have the relation congruent modulo 5. Elements in the different sets have not have this congruent modulo 5 relation. Take 6 and 5. 6 and 5. They have not this have they have no this relation congruent modulo 5. 6 is not congruent to 5 modulo 5. Therefore, elements in the different sets have not related under congruent modulo 5. You follow this point? Take elements in different sets. They have no this relation congruent modulo 5. But elements in the same set, they have the congruent modulo 5. 5 is congruent to 5 modulo 5. 10 is congruent to 5 modulo 5, and so on. Now, these are the important things you have to observe here. I think by these two examples, equivalence classes is clear. Definition of equivalence classes. Definition of equivalence classes and what is the property of that equivalence classes. Now, this okay, that I conclude by saying this. In that video, I have completed one topic. Now it is partition of a set is different topic, and let us consider that in the next video. Thank you.